All right, section 4, we're going to be talking about building functions from functions. And you'll remember that when we did our prerequisite sections for pre-calc this year, that we talked about how to evaluate functions using function notation. And so now what we're going to be doing is we're going to be using operations with functions. So adding, subtracting, multiplying, dividing, and then we're also going to be looking at what's called the composition of a function. So this should be a review from Algebra 2, and when we talk about taking a sum of a function, what you're trying to do here is take two functions and you're adding them together, since that's what the word sum means. So if we were to take the function g of x and we were to add the function f of x, it is as easy as taking 2x plus 1, which is function g of x, and adding function f of x, which is 14x minus 8. And now all I'm going to do is simplify, and I end up with 16x minus 7, and there's our function for the sum of the two functions. So you'll see this written out as g of x plus f of x, or sometimes you'll see a different notation here, where in parentheses you'll see f plus g of x. So it means the exact same thing as taking two functions and adding them together. When it comes to taking the difference of two functions, we're going to do the same thing here. We're just going to be subtracting two functions rather than adding them. And so I can take my 2x plus 1, which is function g, and subtract 14x minus 8, which is function f. And so now you just need to subtract and be a little careful. 2x minus 14x, which is going to give us negative 12x. And here's where people usually make the mistake, is 1 minus a negative 8. So we're going to get plus 9. A lot of times people take 1 minus 8, so just be very careful about that. A different way that you'll see this written, just like the sum of two functions, is you might see f minus g in the parentheses on its own. Understand that's the same thing as just taking the two functions and subtracting them. Finding the product of two functions, you can probably guess what's going to happen here. We're going to take g of x and we're going to multiply it by f of x. And we're going to take our two functions, 2x plus 1 and 14x minus 8, and we're going to multiply them together. And in our case here, we would have to use FOIL. So I would get 28x squared minus 16x plus 14x minus 8. And simplify like terms, so I get 28x squared minus 2x minus 8. And there's the product of two functions. Different way of seeing it, you might just see f and g in the same parentheses, just like the addition and subtraction, and realize here you're just multiplying the two products together. And then we have the quotient of functions, which you can probably guess what's going to happen here is we're going to divide. Now you could take g of x divided by f of x. Because of the next slide that I have here, I'm going to take f of x divided by g of x. And so I'm going to take 14x minus 8 divided by 2x plus 1. This function here cannot be simplified any further, so we're just going to leave it as is. And there it is. Here's our quotient, taking f of x divided by g of x. Here's a different way that you might see it written out. So when it comes to adding, subtracting, multiplying, and dividing functions, it's fairly simple. It's just using your properties of simplifying and adding like terms together. When it does come to quotients, now we will be getting into some situations where you can simplify this a little bit further. We'll be reviewing what's happening when you have rational expressions that you're working with. But for the most case, it's not that difficult of a process. Where some people do have the problems is when we start looking at the compositions of functions, because a lot of times people think that this notation right here of composition of a function means you're multiplying the two functions together, which is not what's actually happening here. Notice that you have an open circle that's being used rather than a dot, which would indicate multiplication. And this here is saying that you're going to take the answer from one function and plug it into the other. That's what a composition of the two are. This right here is saying f of g of x. Okay, that's what this is saying. So what's happening here is we are going to take g of x, we're going to evaluate that, and then we are going to plug that into the function of f. I think it's a lot easier to see in this notation here because of order of operations. We're used to working inside the parentheses first, which means we're going to start by evaluating g of x, take that answer, and plug it into f of x. So to show you an example, here I've got g of x and f of x that we've been working with. And let's say we want to evaluate g of f of -5. So what's going to happen here is I'm going to start with f of -5, and I'm going to evaluate that. So if I look at my function of f, which is up here, I'm going to take 14 times -5, and then I'm going to subtract 8 from it. I want to evaluate all of this first. So inside here, then, I end up with -70 minus 8. And I end up with g of -78. Now, so here we have f of -5 is -78. I'm going to take that answer now, and that's going to now be plugged into our function of g. G is 2x plus 1. So now we're going to take this -78 and we're going to plug that into the function of g. So 2 times -78 plus 1. 2 times -78 is a -156, and if I add 1 to that, I end up with -155 for my function, for my answer of g of f of -5. When you go through some of these, you can plug in values. I think what I'll do here is I'm just going to do one quick more example just to kind of help put this into perspective real quick, then I'll move forward. So let's just say we switch this up here and we take f of g of, I'll just go with a 2. So what I'm going to do here is I'm going to evaluate g of 2 first. So we're going to start up here, and I'm going to take f of, and I'm going to take 2 times 2 plus 1. So I get 4 plus 1, which is 5. And so g of 2 is 5. Now I'm going to take that answer of 5, and we're going to now plug that into the function of f. And we're going to have 14 times 5 minus 8. So then if we take our 14, multiply that by 5, so that gives us 70. And then we want to subtract 8, and we end up with 62. And there's our function. Now, if you look at a composition of functions here, so you have g of f of x, what we're going to do is the exact same thing, but instead of plugging in a number for x, we're going to leave it as x. Here, I'm going to take f of x, which is 14x minus 8, and we're going to be plugging that in. So think of this here as g of 14x minus 8. Now I can take this 14x minus 8, and this is now going to get plugged into our function of g, which means it's going to replace our value of x. So we're going to end up with 2 times the quantity of 14x minus 8 plus 1, which is going to give us 28x minus 16 plus 1, and simplified is 28x minus 15. And there's your function of g of f of x. Just kind of one more example to go through here before we're all done. G of x and f of x, I just put in a rational function this time. So I'm going to go ahead and do, let's go f of g of x. So I know that g of x is x squared minus 4. And now I'm going to take this x squared minus 4, and it's going to be plugged into the function of f, so it's going to replace x. This is now going to give me 1 over the quantity of x squared minus 4 plus 13. Simplify, and I get 1 over x squared, negative 4 plus 13, so then that's going to give me plus 9. And in this situation here, nothing can be simplified, so we leave it just as is. What I'd like you to do coming into class tomorrow is to work out 4 different problems here. So I have 4 functions using addition, multiplication, some composition of functions here. And what I'd like you to do is come up with a expression for these 2 functions using h of x and k of x that are up here on top. So once again, you're bringing these 4 answers with you to class. If you are not sure about them, make sure you come in and get help prior to coming to class. If you have any other questions, make sure you write them down.